course. Serial communication. Our HMI supports many protocol in serial port. For example, the first is our Wecon PLC protocol. So you can connect our Wecon HMI with this protocol directly. And the second serial port the protocol support is Modbus RTU protocol. We also support Modbus ASCO, but it's not very normally used. And the third is the RS user-defined protocol. So you can use this protocol to connect some small sensor. And at the end of today's training, we will also introduce RS485BD module for if you have more devices need to be connected, but the building in a serial port is not number of serial ports is not enough for you. Okay, so let's start with the serial interface. As we knew, LX3 we have 3 serial ports built in PLC. The first is RS422 serial port. We named it as COM1. So it can use to connect our HMI and upload and download the PLC project by the RS422 to USB cable. And you can also use this cable to monitoring the PLC program. And there are also another COM1 port. It's RS485, and this port can be used to connect our PLC, our HMI. So this port support Wecon PLC protocol, but this port doesn't support Modbus protocol and the user-defined protocol. And also you can use this port to upload or download or monitoring the PLC program. And if you use it as a PLC protocol, Wecon PLC protocol, you can also modify the boundary rate. And just remember, this port cannot you cannot use this COM1 port RS48422 and this COM1 RS485 at the same time. And the last built-in serial port is COM2. It's also a RS485, and in this port it can support Modbus RTU or Modbus ASCO or user-defined protocol. For LX5V, it's also the same. COM1 for RS482 and the two RS485 port, but it's different for COM1 now. Actually, it also cannot use with RS422 at the same time for COM1, but in LX5V, the COM1 also supports the RS Modbus RTU and user-defined protocol. So this is the difference for the COM1 RS485 two eyes for LX5V and LX3V. And the last port COM2 is also support upload and download and monitoring the PLC protocol, PLC project, and Modbus protocol, user-defined protocol, and also support PLC link, so you can connect two LX5V to communicate with each other directly. We will mention this function in the next step. Next stage course. So as I just mentioned, for LX3V, the serial port for the COM1 can be modified, and here you can see only the boundary rate and the bit data, and the stop bit can be modified, and the other parameters like a priority cannot be modified. And if you want to modify the boundary rate, you can change the value of D8110. And if you want to use COM2 in LX3V, you need to make some program in your project. The first thing you need to set the value of D8126 to choose which protocol you used in COM2. So as this table can see, if you set D8126 as 1, it means you choose this protocol, this port to use Wecon PLC protocol. And if you set it as 2, it means you choose this COM2 to use the Modbus RTU protocol and the PLC as the Modbus master. And if you set the D8126 as 20, it also means you use the COM2 to use the Modbus RTU protocol, but in this time, the PLC is the master device, and if you set it as 2, so the PLC will be the slave device. Just then is the other device which communicate with the PLC. So 2 means PLC as slave device, and 20 means PLC as the Modbus master device. After we choose which protocol we use, then we should set the communication format. It's about a boundary rate, stop bit, priority, and data bit. Here is an example. If the communication fault is 9600, stop bit is 1, priority is none, and the data bit is 8. So it means we circle is 9600. So it means the bit 7 to bit 4 is 1000. and stop data 0. It means is 1. So it means bit 3 is 0. And the priority here none, and it means bit 2 and bit 1 is 0. This. And then the last data bit is 8. So it means B0 is 1. So we write it here. 1, 0, 0, 0, and 0 to 0. And the last bit is 1. So it's just like this. And so you can see how it look like in the so in the Hertz committed number. So we set it. First the bit is here is 1 or 0, and 3, 0, and 1. So you can see the here bit. So you can see it now. The heraldical number is 81. It's 81. So we use MOV instruction to move H81 to D8120. So after that, we set the communication parameters. Okay, so in the LX5V, the setting will be more convenient. We have a PLC parameter interface to choose the which protocol you want to use, and the communication settings about the boundary rate, stop bit, and priority like this. So if you use LX5V, it's no need to write some instructions in the PLC program. Let's first to the Wecon protocol. This protocol is to use for connect our Wecon HMI to Wecon PLC. So this is the wiring. And just remember, HMI have the two. Some HMI have the two IS485 serial port. So you need to choose depend on your needs. And if you use LX3V, and connect COM2 of the PLC to connect our HMI. So you need set D8126 as 1, and also set the communication parameters. And after you set these two instructions at the beginning of your project, you can continue to write your own command, a PLC project, and then it will communicate with the HMI. And let's move to the second protocol, Modbus RTU. First, I need to mention the Modbus function code. For code 01, it's to read the bit address, and the code 05 is to read the bit address, to write the bit address. And if you want to write many bit address, the function code is 15. And if you want to read the register, like word address, so the function code is 03, and the write code function code is 06. And if you want to write continuous registers, so the function code is 10. And this is the Modbus slave address rules for LX3V, as I mentioned yesterday. It's different for LX3V and LX5V. So please check the table. Depend on your PLC mode. Here is the bit address. Include the M registers, S registers, the timer, the counter, and the input and output terminal. And here is the word address for the D registers, counter registers, and the timer registers. For LX5V, the bit address also contains the timer, the counter, long counter, and high speed counter, M registers, system special registers, and S registers, and also the input and output terminal. And for LX5V, the word address also contains the counter, high-speed counter, and the long counter, and also the special registers and R registers. And here is the instruction, RS instruction, which is widely used in Modbus mode protocol. It has two modes. Here we just mentioned Modbus mode. In Modbus mode, it has 4 parameters. The first parameters is about the 2 parts. The high byte is the slave address. And the low byte is the instruction code. Actually, the function code here we mentioned here. And the second parameters is the start address, which we want to read or write. And the third parameters is the data length. And the last parameter is the start address for the data. If we read the data from other device, we save the data on it. Or if we want to write the data, the value we will set here and write to other device. This is an example when the PLC as the master. So as you can see, we set the PLC protocol and the communication parameters, and then we set the IS instructions parameters. The device we communicate with, the station number is 1, and we want to read the 03 here is to read the registers word address. And the start address here is 64. The length is just 1. And so here the IS instruction, it means we read the data from the slave station number 1, and the register address is 64, and save it the data to the D10. Okay, do you have any questions about this example? And here is just an example for PLC as the master. So you can also find a mode, a demo program in our Wecon support center. It also provides the PLC as the slave device. As you can see it here, we set the value of D8126 as 2 to make PLC as Modbus slave device. And then we set the communication parameters. And the third thing, we need to set the PLC station number by setting the value of D8121. Here we set it as 1. It depends on the serial cable and the environment. We don't have a certain number here, but COM1 cannot for LX3V cannot use as a Modbus protocol. I remember some client connect about 10 Modbus slave to our PLC, but it depends on many situations. Okay, let's move on to the user-defined protocol. This protocol also uses the IS instruction, but these 4 parameters have the different defined here. The first parameter, sorry, here is a mistake here. The first parameter is the head address of the register where we want where the data will be sent. And the second parameter is for the length that to be sent. The third parameter is the register we want to save. If we get the data and then we will save it, start the address from here. The third parameter, and the last parameter is the data length. For here is the example. First, we set the value from D20 to 100 to D202. And there are 5 bytes data: 11, 12, 13, 40, 15, and these 5 bytes here. And then when we triggered M0, it means this instruction will send this 5 bytes of data. And then if he received 4 bytes of data, he will save it, start from D210, and the length here is D1, and we already set it value is 4. Okay, so here is all the protocol can be used in the built-in serial port. Let's move to the last part about RS485 BD module. This module is to extend the serial port, and use it you can connect more device. With this module, the relative instruction is also RS2 instruction. It's the same as the module LX3V ETHBD module we just mentioned yesterday. And this RS2 instruction have 5 parameters. The last parameter is about the starting address of transmit data. And the second parameter is the data length. The third parameter is third parameter is the start address for stored data, and also the 4 parameters is for the length. And the last parameter is the serial port number. Here, if we set it K2, it means the COM2, which is the built-in serial port. If 3, it means COM3. So we can see it here. If we installed the BD board here, so the COM3 is here, and here is the COM4. And if you connect the BD board here next to the LED light indicator, and the COM5 is here, and this is the COM6. So by using the RS2 instruction, you can define which serial port you use. And And please notice, a program could write a multiple IS2 instruction, but only one IS instruction can be triggered at the same time. Just now we showed the IS instruction used in user-defined protocol. And then we showed how the IS instruction defined in Modbus protocol. The first parameter here now is changed to the slave station address, and the communicational command just the function code we mentioned. And the second is also for the start address. And the third is for the address for read or write data. And the third, the third is for the length. And the fourth is for the address to read and write data. And the last also the same, to choose which COM port you use. And also the other related relevant instruction is CPAVL. This instruction is to set the communication port to set the communication format like baud rate, stop bit, and priority. So as you can see here, you can set the station number, communication format by using CPAVL instruction, and the state of the communication will also showed in the second parameters. And the last parameter also to define which serial port you use. Here it means K4 means you use the serial port is COM4. Okay, let's show some example for Modbus RTU protocol. If you want to communicate with this module and set the PLC as Modbus RTU master, the first thing is you need to set the to see the parameter communication parameters. For here, start address is D20, so you set D20 as 81 to show the communication format, and the D26 as 20 to choose a protocol as Modbus RTU master. After we set these two, and you can also set the timeout parameters, and then use CPAVL to set COM4 port, and then we can set the IS2 instruction parameters to read and write data. Let's see it in a video. As you can see it now, use HMI as a Modbus slave and the PLC as the Modbus master. After we use a CPAL instruction to set the PLC communication parameters, and now we can use Modbus protocol to communicate with our HMI. As you can see here in the video, I use M2 here to write the bit address of the HMI. I can set the bit on or off. By using IS2 instruction. So here we set the HMI parameter station number is 1 and use a 05 function code to write the bit address, and the address the HMI Modbus address is 0 and the length is 1, so we just write the HMI bit address 0 and the port we choose is COM3. Okay, let's see how we read the word address from HMI. Also use IS2 instruction and also set the HMI Modbus station number is 1 and use the function code is 03 to read the value of the word address. And the address also is 0 for this word address, word registers, and the length is also 1. And save the data we get and to the D600 and use COM2 here, COM3 here. So now I change the value to 7, and you can see the value of D600 is also changed. And we can also write the value to HMI's address. So here, as you can see, now it changed to 89. Okay, this is how we use the HMI as Modbus master by using LX3V RS485-bit BD board. And also we can use this BD board to make PLC as Modbus slave. Here, as you can see, I already set the HMI as Modbus master. And the bit address is 1. Here, bit address is 1. And the first word address is 0. The third PLC address is 10. So now we also set D20 SH81 means corresponding to here the communication parameters, and set the PLC as Modbus slave by set D26 as 2, and also set the station number of our PLC, set it as 1. According to here, we already to set our HMI to communication with the station number 1 device by using Modbus RTU instruction protocol. And then we triggered CPAL AVL to make the PLC as a Modbus slave. And after all above is done, so as you can see, when I change the state of M1 in our PLC, the same address will be changed in our HMI, because M1 is its Modbus address for LX3V here. It's also 1. And as you can see here, if we set the Modbus slave address 10 as 189, so also here in PLC, D10 is also equal to, it's also actually it's the same registers. D10 in PLC is also the Modbus address 10 in HMI. And now we change the bit value, and it also changed in HMI, and make the D0 value to D10 by using MOV instruction. Okay, now so one thing I forgot to mention here is for this bidding mode, you cannot use it to monitoring the PLC communication with PLC directly. So you can only use it by Modbus RTU protocol to communicate with our HMI. And in our Wecon Support Center, it provides more demos here. Do you have any questions about this IS485 BD module? For all the communicating BD module, it cannot use this BD module to LX5V. So it's the same. if you want to use this BD module, this type BD module, you need to use LX5V R2RS485 BD module, just like the SNet module, BD module. Okay, do you have any other questions? Sorry, it doesn't support. You can see it here, as I just mentioned. Here, COM3, COM4, COM5, COM6 is the serial port in the BD board, and it doesn't support HMI monitoring protocol. What's the maximum range? Also, pass-through works. Yes, the pass-through can works on COM3. The pass-through just the communication is working normally, so you can use the pass-through. Distance is based on the baud rate and the environment, so it's not a certain distance I can provide. The higher baud rate, the shorter distance. And if you want to use Alex 3VIS2 IS482 485 module, you can also need to check the PLC firmware version. And for all the BD module, if you need to power off the PLC when you install the BD module on it. Here. Otherwise, it may cause some hardware issue. Okay, any other has some questions? If you want to know some others, you can leave your message in our group. So let's can start today's activity to finish today's training. Here we have 22 participants. I'm number one. But awesome. Here is the number. Number one is me, so I didn't make the range from here to the last one. Here now is 22. So okay, let's choose the first. Okay, 20. So the last 22, 21, 20 here. Okay. Okay, just I say someone is still here. This one. Hello. A friend from Russia. And now it become 21. Okay, so I think it's not less necessary. So we choose the second lucky person. 50. 15. 1, 2, 3, 4. 21. 20. 19. 21. 20. 19. 18. 18. 17. 16. And Raja Fadu. Raja Fadu. Here. So here for here. 1, 2, 3. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Yes. 2. Hello, these two friends. Please leave your email address. So we will have a register. And after all the training was finished, we will provide our Wecon tool set to you. Okay, so just remember to provide your after class exercise in time, and the next training will start in will on Friday. It's about LX3V4 PG module to send output to output pulse by this module. And the next Monday we will have a online meeting. I will make some explain to our exercise after class exercise, and the next week we will finish our training next time, and to set the to begin today, this term's final exam. Hope you all can pass this exam and get the get a prize. Okay, today's training is finished. Thanks for your attend. See you next time. Bye bye.